Today we're learning the basic logical gates. Logic gates are tiny decision makers inside computers. They take one or more inputs, each either 0 or 1, and output as 0 or 1. If you understand gates, you understand the basics of digital electronics and how computers think. We'll use two meanings: 0 means off, or false. 1 means on, or true. For every gate, we describe its behavior using a truth table. A truth table lists every possible input combination and the output for each one. First, the simplest gate, NOT. NOT has one input. It flips the input. A represents the input, and Q represents the output. If the input is 0, the output becomes 1. If the input is 1, the output becomes 0. NOT is also called an inverter. Next, the AND gate. AND has two inputs, A and B. The output is 1 only if both inputs are 1. Otherwise, the output is 0. A good way to remember this gate is only true if A is true and B is true. Now the OR gate. This gate outputs 1 if at least one of the inputs is 1. It only outputs 0 when both of the inputs are 0. So, OR means A or B, or both. Here's a new idea. If you put A, NOT, on the output of a gate, you get a new gate. The NAND gate means NOT AND. So it does AND first, then flips it. That means that NAND outputs 0 only when both inputs are 1. Every other time, it outputs 1. Now the NOR gate. NOR means not OR. OR outputs 1 if any input is 1. NOR flips that. So NOR outputs 1 only when both inputs are 0. Fun fact, NAND and NOR are very important because you can build any digital circuit using only NAND gates, or only NOR gates. Now the XOR gate, which stands for exclusive, OR. XOR outputs 1 when the inputs are different. If both inputs are the same, XOR outputs 0. So XOR is perfect for questions like, exactly one of these conditions is true. Let's build a small circuit from gates. We'll define X equals A and B. Y equals A or B. Z equals not X. And finally, Q equals Z and Y. Now we can compute output step by step using a table. Let's do all for input combinations. If A is 0 and B is 0, X is 0, Y is 0, Z is 1. So Q is 0. If A is 0 and B is 1, X is 0, Y is 1, Z is 1. So Q is 1. If A is 1 and B is 0, X is 0, Y is 1, Z is 1. So Q is 1. If A is 1 and B is 1, X is 1, Y is 1, Z is 0. So Q is 0. That output pattern, 0110, is actually the XOR pattern. So this whole circuit behaves like XOR. This is a good example of how different circuits can behave the same way. Quick recap. NOT flips and needs both inputs to be 1. OR needs at least one input to be 1. NAND is the opposite of AND. NOR is the opposite of OR. XOR is 1 only when the inputs are different. Thank you for watching this video about gates. I hope it helped you. If it did, please like and subscribe.